All right, so let's get into it. So in this case, we'll be looking at the fourth type of partial fractions, in which we have repeated factors as denominators. So in this case, this is the case where we have the repeating denominators. So let's look back at the list of types of partial fractions that we've had. Let's see them again. So we started working with what's it called? We worked with the type with the non-repeated linear factors, the factorizable denominators, the non-factorizing, and now we are looking at the case with the repeating denominators. So let me help you explain. Anytime we have the power of 2, like when you have an expression that is all to the power of 2 or 3 or so forth, and so on, is a repeating denominator. And the way we deal with it is as follows. So in this case, so they say let's say, for example, this is the partial fractions that we have that we want to, the fraction we have that we want to resolve into partial fractions. So how do we deal with something like this? We are going to say, okay, this is going to be a case where we have x squared and we have x plus 3 all squared. Your x is squared, which is a repeating denominator for it, and your x plus 3 is also squared. 2x plus 3 over x squared, x plus 3 all squared. So how is our fractions going to align? It's going to form something like this. We're going to have a over x, and we're going to have your a over x squared, meaning that you take the term itself, then you take it as the x squared like that, and then we're going to plus b, rather, let me continue, it's supposed to be b. Then we have c over x plus 3. Then we have finally we have d over x plus 3 all squared. That's basically the idea of this. So that's how we are going to use it for our questions. So let's just, without saying too much, let's jump to the first question. The question 1 says, resolve 3x minus 2 over x plus 1 all squared, x minus 3 all squared into partial fractions. So how do we deal with something like this? So we will have, let's start. We have 3x minus 2 over, what do we have? X plus 1 all squared, x minus 3 all squared. So of course we are going to have it in the mock-up fraction, in which our answer is going to look like is going to be of a over x plus 1. Now I'm going to have b over x plus 1 all squared. Then we're going to have c over x minus 3, and finally we are going to have d, which is going to be over x minus 3 all squared. So these are the way our answer is going to look like. Our x, then x plus 1 squared, then x minus 3 all squared. So of course what we're going to do next is to sum up our right hand side, our fractions here. So if you look at the fractions here, for this and this, the LCM is just the one with the squared, because if you look at this, let's take the LCM for example. So we have LCM of x minus 1 all squared. So of course we divide by x minus 1. X minus 1 cut x minus 1 is 1, and this is going to give us x minus 1. So you are prompted to cut by x minus 1 again. This is already 1, so this is now 1. If you multiply this, you're having x minus 1 all squared as the LCM. So that means that x plus 1, oh, it was a plus, x plus 1 squared, and of course this would also follow up to be x minus 3 all squared for there. So let's go now. So if this cuts this, you're going to have your answer. I should have let it be bigger. Okay, let me elongate it here. So this is going to be a, so you're going to have it to be what? A. Now everything here cut everything here. This is still remaining 1, and this is remaining all squared. So that's going to be x plus 1 x minus 3 all squared. Then plus, now what do we have as b? This we cancel this, and we're going to have b open brackets x minus 3 all squared. Then plus, what do we have? C. This we cut one of this, and we're going to have, that's going to be c open bracket what? X plus 1 all squared x minus 3. Then we have d. So in your own work, so as not to confuse you, this is still the LCM here, x plus 1 all squared x minus 3 all squared, and d, remember this we cancel this, and we're going to have it to be x plus 1 all squared left. So remember, that's exactly what we have as 3x minus 2 over x plus 1 all squared, x minus 3 all squared. All right, so now that we have done that, now it's time. Now we know our denominator in both cases are the same, so we just work with the numerator. And what do we have? We have that 3x minus 2 is equals to, what do we have? We have a open bracket x plus 1 x minus 3 all squared. Then we have plus b, and b tells us that it is x minus 3 all squared. Then what do we have as c? C says x plus 1 all squared, x minus 3. Then d is x plus 1 all squared. Alright, good. Let's bring that into view here. So now it's time for us to do the expansion, so that we have 3x minus 2 equals to a. Then we have x plus 1 here. So let's expand x minus 3 all squared. It will give us x squared minus 6x plus 9. You are free to go and confirm. Then let's expand this b now. We are going to have it to be x squared minus 6x plus 9 as well. Then plus c. Our x plus 1 all squared will give us x squared plus 2x plus 1. Then it still has x minus 3 there, so that's x minus 3. Then plus d. D has x squared plus 2x plus 1 as well. So now it's time for us to do this expansion here and this expansion here, so we can bring everything all together. So on the left hand side we had 3x minus 2 equals to a. So now let us do the expansion here elsewhere, so that our work can be neat. So of course we had what on this side? We have x plus 1 x squared, so we have the expansion of x plus 1 x squared minus 6x plus 9. So that's what we take x. Now we have x squared minus 6x plus 9. Then we have plus 1 and x squared minus 6x plus 9. So x times x squared is x cubed, x times minus 6x is minus 6x squared, x times 9 is 9x, then plus x squared minus 6x plus 9. So let us simplify things by saying this is x cubed on its own, minus 6x squared plus x squared give us minus 5x squared, plus 9x minus 6x is plus 3x, then we have plus 9. We took this, and we count this, so we have this as our answer. So we're going to have this to be what? A open bracket, this and this gave us x cubed minus 5x squared plus 3x plus 9. Remember, b still had this at the end, which is x squared minus 6x plus 9. Then now the next thing for us to do is to actually open the bracket for c as well. So of course we had what? X squared plus 2x plus 1 and x minus 3. So let's take x squared, and we have x minus 3, then plus 2x, x minus 3, then plus 1, x minus 3 as well. Alright, so what do we have? X squared times x is going to be x cubed. Okay, maybe I should zoom in a little bit so it's closer to you. X cubed. So x squared times minus 3 is minus 3x squared. 2x times x is 2x squared. 2x times minus 3 is minus 6x. Plus 1 times x is x. Plus 1 times that's minus 3. So what do we have? We have x cubed. Minus 3x squared plus 2x squared is minus x squared. Minus 6x plus x is minus 5x. Then we have minus 3. This is the answer to that. So we have that to be x cubed minus x squared minus 5x minus 3. Then we have d to be what? X squared plus 2x plus 1, as this one as well. So of course it's time to still put things together. Okay, all right, so that's going to give us 3x minus 2 equals to, now let's expand. We have a times x cubed is ax cubed minus 5a x squared plus 3ax plus 9a. This is what we get after expanding and multiplying through this. So we do the same thing for this one. This time this will give me bx squared minus 6bx plus 9b. Then we continue to say plus cx cubed minus cx squared minus 5cx minus 3c, then plus dx squared plus 2dx plus d, after we expand that as well. All right, that is actually quite a lot. We are already 10 minutes in and we are just about to start solving. This is interesting. All right, so let's go on. So we've expanded fully now. What do we do next? It's time to put it in terms of power of 3, power of 2, power of 1 and the likes. So let's go on. We have 3x minus 2 equals to, what do we have? Power of 3 first. So for power of 3, let's just look at it. So we have a and c to give us x cubed. So we have ax cubed and cs cubed. Now the next thing is the power of 2. So let's say plus. Now let's look at all the powers of 2 that we have. We have minus 5a minus 5a. Then we have plus b minus c. Then we have what? Plus d. Those are all the powers of x squared. Now it's time to look for the powers of x. What do we have here? We have 3a. It's minus 6b minus 6b minus 5c plus 2d. That's the power of x. Now it's time to look for the constants. I can see here 9a. So 9a plus 9b minus 3c here. Then finally plus a d. So of course you should always count that you have everything. Let's count 1 2 3 4 5 6 7 8 9 10 11 12 13 14. We have 14 terms here. Let's count it here. 1 2 3 4 5 6 7 8 9 10 11 12 13 14. So 14 as well. So we've gotten to this part and we have things to be correct so far. So now what do? We need to equate the equations now. So by comparing, so we know that if you look at the left hand side, we don't have any x cubed and x squared term. So hopefully that will help us solve some things. So from here we know that your equations are going to be a plus c equals to 0. That's for your x cubed term. A plus c is 0. There's no x cubed term there. Then here we have this x squared. That's going to be minus 5a plus b minus c plus d is also equal to 0. So let's do equation 1, equation 2 as well, right? Then now the x term, all of this will give us 3 here. So we have that 3a minus 6b minus 5c plus 2d will be equal to 3. That's our equation 3 as well, right? And we have this final thing which says 9a plus 9b minus 3c then plus d, which is equals to minus 2. That's our equation 4. So we have 4 equations to solve, which is that. And how do we handle them? Now this is quite a little bit of sense that we're going to do, because the ones we've been doing so far have been in terms of 3 things, maybe a, b and c. Now we've gotten to another level here, a, b, c and d, and let's just look into solving it. But basically the idea doesn't change. All you just need to do to look is for 2 simultaneous equations that contain the exact 2 terms, and that is it. And from here now if you look at your equation 2, 3 and 4, they actually all contain 4 and 4 terms, a, b, c, d, a, b, c, d, a, b, c, d. So I guess the wisdom that is coming to me right now is that why not I try to eliminate something from maybe 2 of the equations. So if I try to look at equation 2 and 3, if I eliminate one equation, one letter from there, then I may be able to get something. Maybe create another thing from 3 and 4. I may be able to get something from there. So that's just kind of the wisdom that is coming to my head right now. And let's see if it will work. So my strategy to solving this thing is that, okay, you know what? Let's go to equation 2 and equation 3. Let us eliminate d out of it. So if we eliminate D, let us see what we want to get from there. So let's see, the strategy is eliminate D from equation 2 and 3. Of course, from equation 2 and 3, what do we have? Equation 2, we had minus 5a plus b minus c plus d equals 0. So that's minus 5a plus b minus c plus d equals to 0. I hope I had that right. Yep. Then equation 3 says 3a minus 6b minus 5c plus 2d. So that is 3a, okay, I can't really get that, minus 6b minus 5c minus 6b minus 5c plus what? 2d equals to 3. 2d equals to 3. So how do I finish this up? I'll say, okay, this is my equation 2 and this is equation 3. Why not I multiply this equation 2 by, I want to eliminate d. If I multiply this one by 2 and multiply this one by 1, I'll be able to eliminate d, and like after subtracting, because then the coefficient will be the same. So I have that to be minus 5a okay, times 2, that's minus 10a plus 2b minus 2c plus 2d equals to 0. And here I have 3a minus 6b minus 5c plus 2d equals to 3. So now let me eliminate by subtracting. What do I do? Minus 10a minus 3a is minus 13a, right? So now what do I have here? 2b plus 6b is going to be 8b. Now minus 2c plus 5c is plus 3c, which is equals to, okay, we subtracted, right? So 0 minus 3 is minus 3, which is equals to equation 5 at this point. So now we have equation 5 to work with. So let's go on from there. So this is equation 5. Now let us see. So right as we eliminated d from our equation 2 and 3, I'm thinking we could also do the same thing for equation 2 and 4. Now I could have decided to use equation 3 and 4, but I'm leaping before looking, like I always say. Now I'm checking it very well. If I look at equation 2 and 4, both of them have dd, so it's easier for me to eliminate d from equation 2 and 4 without having to multiply anything. So I'll get a brand new equation from there as well. Okay, so let's see now. Okay, so I'll say as well, eliminate d from equation 2 and 4. Already this is equation 2, so let's just copy from there. That's minus 5a plus b minus c plus d equals to 0. How does equation 4 tells us? It tells us 9a plus 9b minus 3c plus d. 9a plus 9b minus 3c plus d equals to, I guess it says minus 2, so equals to minus 2 as well. So if we subtract it now, what do we have? This was equation 2 and this is equation 4. So if we subtract it so as to eliminate d, what do we have? Minus 5a minus 9a will give us minus 14a. Now b minus 9b will give us minus 8b. Now minus cb plus 3c, because this is minus minus, that's going to be plus 2c equals to 0 minus minus 2 is a 2. So in order to also make my work easier, I would see that each term here is divisible by 2. So I can say this is what? Minus 7a minus 4b plus c is equals to 1 by dividing 2 by 2, and that becomes what? My equation 6. So now if I look at equation 6 now, I have two equations that have 3 terms. So I have a, b, c, which is this and this. And now again, I told you earlier on that the actual target is that we solve 2 simultaneous equations that have only 2 terms. And now I told you earlier on that this topic requires you to be smart and creative. You need to play with algebra. So how do I do this now? We have 2 simultaneous equations that have 3 terms. Well, 2 simultaneous equations have the 3 terms. It's not possible to solve that. You need the same number of equations for the same number of terms. So how do we reduce this equation 5 and 6 to get your a and b? if I look at my equation 1, which was where that gave me the inspiration, my equation 1 had a plus c equals to 0. So from there, I could get an expression for c. If I get an equation for c, I can substitute it in my equation here, and I will only work with a and b only, which I can solve. So I will say, oh, okay, you know what? Substitute, okay, from equation 1. Equation 1 tells me that a plus c is equals to 0. I know that c is going to be minus a, which I can call as equation 7, right? So I can say substitute c equals to minus a in equation, the two simultaneous equation you got, that's 5 and 6. So for your equation 5 says minus 13a plus 8b plus 3c equals to minus 3. That's minus 13a plus 8b plus 3, open bracket, minus a equals to minus 3. So that is minus 13a plus 8b minus 3a equals to minus 3. So minus 13a minus 3a is minus 16a plus 8b equals to minus 3. That is my equation 8. So we've solved that to this point, equation 8. So then the next thing for us to do is to substitute it as well in equation 6. This is equation 6 here. So of course the equation 6 tells us that minus 7a minus 4b plus c equals to 1. That was equation 6. So if I substitute c equals to minus a for it, I will have minus 7a minus 4b plus minus a is equals to 1. So I have minus 7a minus 4b plus times minus is minus a, which is equals to 1. So minus 7a minus a is minus 8a minus 4b, which is equals to 1, which is my equation 9. So I have successfully reduced everything into two equations that had only two terms. So I have the two equations to be minus 16a plus 8b equals to minus 3. Now I have minus 8a minus 4b, which is equals to 1. Now this took a lot of time, and I can even see the time mark now. Now this is at the 22nd minute of work with this question. So of course, what do we do next? We could actually solve, we have to solve these two equations, but for the purpose of keeping my video short and everything, I'm not going to solve this simultaneous equation with my hand. I'm just going to make use of the calculator at this point, because this one is easy for us to do. So I've put it in the mode, and I have here to be minus 16a plus 8b. So I have minus 16, 8, minus 3, minus 8, minus 4, 1. I hope things are correct. So a is 1 over 32. I need to even confirm with the textbook that I am right. And b is what? Minus 5 over 16. All right, let me confirm with the textbook. So from here they got, yes, I am actually right. A is 1 over 32. And okay, they've gotten c as well. So since we've gotten a and b, everything becomes easy from there. You can see, recall, c is equals to minus a. So if c is minus a, we are going to have c is minus 1 over 32. So the next step is for us to just find b, and to find d as well. But I mean, your equation d, we can just substitute it in any of these equations that we've already had now to find equation, to solve for d. So you can just say, let's substitute it in equation 4. Substitute a, b, c, d. Substitute values for a, b, and c for a, b, and c in equation 4. So equation 4 told us that 9a plus 9b minus 3c plus d equals to minus 2. Okay, so we have what? 9 open bracket 1 over 32 plus 9 open bracket minus 5 over 16 minus 3 open bracket minus 1 over 32 plus d equals to minus 2. So d is going to be what? Let me just get this entire value and add it to minus 2. So that's going to be what? 9 open bracket 1 over 32 plus 9 open bracket minus 5 over 16 plus that's minus 3 open bracket minus 3 open bracket 3 open bracket minus 1 over 32. That gives us minus 39 over 16. If you take it to the other side, it's become minus d is equals to minus 2 plus 39 over 16. So that's going to be minus 2 plus 39 over 16, which gives us 7 over 16. Right. So now that we've gotten a, b, c, and d, it's time for us to put our equation in order, and that is it here. Okay. Okay, I use this page for something else. So let's see. So what was our mock-up now? We had a, our mock-up of our answer was what? So we had let's see, our equation says 3x minus 2 over x plus 1 all squared x minus 3 all squared is equals to a over x plus 1. We got a to be 1 over 32, so that's going to be 1 over 32 x plus 1 plus what was b? We got b to be minus 5 over 16, so that's going to be minus 5 over 16 x plus 1 all squared plus, now what do we have for the next thing? We have c. C is minus 1 over 32, so that's going to be minus 1 over 32 x plus 1 all x hold on, I think that's x minus 3, right? Okay, that's going to be x minus 3, so that's going to be x minus 3. Wow, it's not easy at all. Then we have d. D was what? 7 over 16, so that's 7 over 16 x minus 3 all squared, and that is it. That's the solution to the work. It took pushing 30 minutes of solving for us to do it, but again, I hope you really appreciate the idea of all of this. Now it is kind of very easy. The concept behind the work is kind of easy. It is long, like it is long. I'm not even going to, like, this is long. If I was doing it on my own, not that I was teaching it, it's probably going to take me half the time, but still solving something for 15 minutes for someone like me with a lot of experience is still a lot. But I don't want you to despair. I want you to actually like take it and try to put the effort, because it's going to do a lot of things to your algebra skills, regardless of if you are able to solve this perfectly or not. So yep, I really want you to take up the challenge as well. But yeah, this is generally the idea. The idea just comes from this 4 simultaneous equation here. Always stick to the process. The process is that you are going to try to get 2 simultaneous equations that have the same exact things. So you just have to find one. Like in this case, I tried to reduce 2 and 3 to have what's it called? To have to eliminate d. I did it for equation 2 and 3, so I got equation 5. I did equation 2 and 4 to get equation 6. Then from there, I brought them all together and further find a way to get rid of c from there. Then after figuring that part out, I'm able to just like solve my simultaneous equation. And of course, in order to simplify your work, you may also want to consult an additional source for solving this simultaneous equation, because if not, your work is just going to be bulky and long. Well, that is it for this particular solution. I hope you are able to do something similar with it as well. I really hope so. And that's it. We'll catch up in the next one.